We just got finished saying that the derivative of a sum is the same as the sum of the derivatives. But the same is not true about the derivative of a product or the derivative of a quotient. I'm going to prove it to you. The example here didn't print into your notes, so what that should say is find the derivative with respect to x of x times x. So what we already know is that the derivative with respect to x of x squared, I can use the power rule, is 2x. But notice if I try to use this non-rule, which is that I can find the derivative of a product by just finding the product of the derivatives, then I would say, I'm going to write this in red so that we know it's wrong. The derivative with respect to x of x times x, the derivative of x is 1. The derivative of x is 1. 1 times 1 just makes 1. That's not the correct derivative. The correct derivative is 2x. So I put that here to kind of try to cement it in, because later in the year, when we're kind of working fast and not thinking, some calculus scholars try to make up a shortcut and take the derivative of a product by just finding the product of the derivatives. That is not correct. It won't work. If you do want to correctly want to find the derivative of a product, we use what is called the product rule. So if u and v are functions of x and you want to find the derivative of their product, we have to actually find this sum. That's the first function times the derivative of the second plus the second function times the derivative of the first. So a couple different ways you could think of that. When I think it in my head, I think the first times the derivative of the second plus the second times the derivative of the first. Or some people think of the two functions as u and v and say u dv plus v du, or uv prime plus vu prime. However you think about it, you need a combination of the derivative and the original function, and we need both. So the original function u times the derivative of v plus the original function v times the derivative of u. So we'll practice that here. So we did a problem at the end of the sum and difference rules examples where we had a product, and in order to figure out the derivative, we multiplied the two polynomials together so that we could use the sum and difference rule. So we're going to do another example kind of like that. We'll do it both ways, one by multiplying the polynomials out, and one where we try to use the product rule, and we're just going to prove to ourselves that we get the same answer. In the AP test, do whichever one you think is faster or you're less likely to make a mistake on. But notice that for non-polynomial functions, so exponential functions, trigonometric functions, there won't be a way to multiply it out first so that you can avoid using the product rule. There will be times where you'll have to use the product rule, so we do need to still memorize it. But try this one here. We'll try it both ways just to make sure we get the same answer. So if I want to take the derivative with respect to x of this product, x squared plus 3 times 2x cubed plus 5x, one approach is I could multiply those two polynomials together. So that takes 4 multiplications, and there's a pair of like terms, so I can simplify that. I'm going to get the derivative with respect to x of 2x to the 5th plus 11x cubed plus 15x. We could notice that that's the same. So alternatively, I could use the product rule. So the first function is this x squared plus 3. The derivative of the second function was 2x cubed plus 5x. So I'm going to multiply by the derivative of that. The 3 comes to the front to multiply to make 6x squared. The derivative of the second. Plus the second function times the derivative of the first. We're just going to multiply this out and prove to ourselves we get the same answer. So there you go. This takes multiplying out too. But just to compare the answers, notice that this, on the AP test, if you left your answer like this, at least in the free response section, that gets full credit. And it's likely on the multiple choice section that this is how the answer choice is written. All right, so let's do this one together. I'll let you try the middle one on your own. Here, if I want to find the equation of the line tangent to f of x, I've been given an ordered pair. So the thing I need is the slope. I'm going to find slope by finding the derivative. I'll start by finding f prime of x. This is a big idea. I don't think I've said it yet to you. We've been asked to find the derivative of f at the place where x equals 1. That's my x value here. But you can't put the 1 in for x first and then take the derivative, because you'll almost always give yourself a constant, and the derivative of a constant is 0. So what we want to do is find the derivative first. I'm going to label it f prime of x. We're going to evaluate that derivative at the place where x equals 1. So f prime of x, I'm going to think of this as first times second. My first function is x cubed minus 3x plus 1. My second function is x plus 2. I'm going to use the product rule to find this derivative. So product rule, first times the derivative of the second is going to be x cubed minus 3x plus 1 times the derivative of the second. The derivative of x plus 2 is 1, because that's x to the first. The 1's going to come down to the front. X to the 0 is 1. Or you could think that to yourself, okay, x plus 2 is linear. What's the slope of that line? The invisible one that's multiplying the x. Okay, that was first times the derivative of the second plus the second times the derivative of the first. The derivative of x cubed is 3x squared minus 3. The derivative of 1 is 0, so I'm just going to stop right there. Notice I don't have to multiply this out. I've been asked to figure out the slope of the tangent line at the place where x equals 1. So now what I want to do is find f prime of 1. That's going to be me taking the f prime of x rule, and everywhere I see an x, replacing it with 1. So this is going to be 1 cubed minus 3 times 1 plus 1, all times 1, plus 1 plus 2, 3 times 1 squared minus 3. It's going to be, this is 1 minus 3 plus 1 plus 3 times 1 squared is 3 times 1 is 3 minus 3, that's going to be a 0. This is 1 minus 3 plus 1, 2 minus 3. This is negative 1 is my slope. So I'll write myself a little note that that's m. Here's my x1 and y1. So I'm going to write y minus negative 3, so y plus 3 equals negative 1, x minus 1. That's the equation of the line tangent to f of x at the place where x equals 1. Just like the derivative of a product is not the same as the product of the derivatives, the derivative of a quotient is not the same as the quotient of the derivatives. We need what's called the quotient rule to find the derivative of a quotient. Remember, a quotient, once you get to algebra 1, we stop using a division sign, this guy, to indicate division, and we use fraction bars. So this is going to be, if I want to find the derivative of a function that's written like a fraction. So you can see the notation from your textbook up there. Most of the time, the calculus students I run into prefer this version of the rule, so I'll tell you what I use. If I think of the quotient as a function in the numerator, which I call the high function, and a function in the denominator, which I call the low function, then the quotient rule says the derivative of that quotient is low times the derivative of the high minus the high function times the derivative of the low divided by the low function squared. So you might find joy in saying low d high minus high d low all over low squared, which is what I learned when I was in high school, and I've always remembered it, so you might prefer it. Or feel free to use one of the versions that's in the box up at the top. So for this first example, if I want to find the derivative with respect to x of this quotient, x over x squared plus 1, that's going to be the low function, which I think is x squared plus 1. Ooh, let me try writing that one more time. X squared plus 1, which is the low function, times the derivative of the upper function. Well, the upper function is x. The derivative of x is 1. Minus the upper function, high, multiplied by the derivative of the low down function. The derivative of x squared plus 1 is 2x. All over low squared, that's x squared plus 1. That's a 1 squared. So again, on the AP test, feel free in the free response section to leave your answer unsimplified. That would get full credit. Let's take a look at the next example. If I want to find the derivative with respect to x of 5x squared over x cubed plus 1, that's going to be x cubed plus 1. It's going to be x cubed plus 1, the low down function, times the derivative of the high. That's 5x squared's derivative is 10x, minus 5x squared, the high function, times the derivative of the low down function, 3x squared, all divided by x cubed plus 1 squared. So this is a good time to remind you that anytime we write this, it looks like another difference quotient. I have a big fraction and I have a subtraction problem in the numerator. So we've seen stuff like that before. Just notice that it doesn't happen to matter here, but this subtraction sign needs to get distributed over whatever other functions might be happening after that subtraction sign. So we'll do some more examples where you see that. Okay, so a couple of these problems, those are good practice to make sure that we've kind of taken in these rules for finding derivatives of functions that are made up of multiple pieces. So remember, if I want to find f prime of 2, I can't really find f prime of 2 until I find an expression for f prime of x, and then I can substitute 2 in. So if I'm looking at part A, f of x is 2 times g of x plus h of x. So f, this is letter A. F prime of x, this is a sum. So to find the derivative of a sum, I find the sum of the two derivatives. So the derivative of 2g of x, that's a constant multiplier, 2, times the function g of x. So it's going to be 2 times g prime of x, plus the derivative of h of x is called h prime of x. Now that I have an expression for f prime of x, I can evaluate it at 2 to find f prime of 2. So I would say f prime of 2 is 2 times g prime of 2 plus h prime of 2. In this case, 2 times g prime of 2 is negative 2 plus 4. That's negative 4 plus 4, which is 0. Let's do letter D next. All right, letter D. F of x is g of x divided by h of x, which means if I need to find f prime of x, I need to use the quotient rule. So f prime of x. So I'm going to think of the g of x function as the high function and h of x as the low function. It's going to be h of x times g prime of x. That's low d high minus the high function g of x times the derivative of the low down function all over the low function squared. That's h prime. So when I need f prime of 2, that's going to be h of 2, which is negative 1, times g prime of 2, which is negative 2, minus g of x. So g of 2 is 3. H prime of 2 is 4. All over h of 2, which is negative 1 squared. So it's going to be positive 2 minus 12 over 1, which is negative 10.